In this video, we'll be using law of cosines to solve our case 3 and case 4 type oblique triangles. That's side angle side and side side side. There are 3 officially law of cosines. I really think of this as a single formula. The only thing that makes them different is just rearranging the variables. Oh, I think of this one kind of in words. Looking at our first one, it's the first side squared equals the other two sides squared and added together minus 2 times those two sides that are on the right side of the equation times cosine of the angle that goes with the original side. I know. I mention all the time about what I do to remember, but so you got to come up with your weird thing to help you remember. That's what I do to help me remember it. And then I don't have to memorize 3 formulas. All right, let's solve the triangle. I know it's not going to be law of sines because I don't have a known pair. If I can't do law of sines, I'm going to use law of cosines. Here we're given 3 sides. So all you have to do is pick one to start with. I'm going to just start with 4 because it's first. So law of sines, or law of cosines, it's one of the sides squared equals the other two sides squared and added together minus 2 times those same sides that are on that same side, the 3 and the 6, times cosine of the angle that goes with the side that's all by itself. That was side A, so this is going to be angle A. And now we solve for cosine. This is just a bunch of cleaning up in your calculator. $16 equals 45 minus 36 cosine of A. Negative 29 equals negative 36 cosine of A. Divide, those two negatives will divide out. And now we're ready for inverse cosine to get our A. A equals cosine inverse of 29 over 36. And we're going to plug that into our calculator and round to the nearest hundredth. Angle A equals 36.34 degrees. Now we need to do the same thing to find a second angle. So this time I guess I'll use side B first. First side squared equals the other two squared and added together minus 2 times those two sides times cosine of the first side. Now we'll just clean up. Combining like terms. Subtracting. Dividing. And then we're ready for cosine inverse. Angle B is going to be cosine inverse of 43 divided by 48. Plugging that into our calculator and rounding to the nearest hundredth, we get angle B to be 26.38 degrees. Remember, what we're doing is we're solving the triangle, which means find all the angle measures, all the sides. We have the 3 sides, those were given. We found 2 angle measures, but now we need to find the third one. Our angle C We know they all have to add up to be 180 degrees, so we're just going to take 180 minus what we got for A minus what we got for B, and that'll give us our angle C, 117.28 degrees.
Let's see how we'd apply law of cosines to an application problem. A motorized sailboat leaves Naples, Florida, bound for Key West, 150 miles away. Maintaining a constant speed of 15 miles per hour, but encountering heavy crosswinds and strong currents, the crew finds after 4 hours that the sailboat is off course by 20 degrees. How far is the sailboat from Key West at this time? Through what angle should the sailboat turn to correct its course? And how much time has been added to the trip because of this? We're going to round all of our answers to the nearest hundredth. It's important we start with a good diagram. So here we have Naples. Key West is actually almost due south. And that's 150 miles away. The heavy crosswinds put the sailboat off course by 20 degrees. We were starting at Naples, but we ended up going 20 degrees askew. And they were going 15 miles an hour for 4 hours. So they traveled 60 miles. So part A asks us, how far is the sailboat from Key West at this time? So in part A, they're asking us to find this distance here. I think I'm going to call it A for part A. All right, so we have one angle and 3 sides in the conversation, so that tells us law of cosines. And we always have to start with the side that's opposite our angle. So we'll have A squared equals 150 squared plus 60 squared minus 2 times 150 times 60 times cosine of 20 degrees. All you need to do is put this, you can just put this whole thing in your calculator all at once, and that'll give us A squared. So you could just go ahead and put the square root around it and then put that in your calculator all at once. Let's do that, and rounding to the nearest hundredth, we get A to be 95.84, and our unit is miles. Part B asks, through what angle should the sailboat turn to correct its course? Round to the nearest hundredth. If the boat continued its course, it would be traveling like this in this direction. So it wants to know how much it has to turn. So we're looking for this angle right here. You'll notice that that blue line is straight, so that's 180 degrees. If we could figure out what this angle here inside our triangle was, we would know that that green angle that we need to find for part B, so I'm just going to call it angle B, would have to be supplementary to that. So let's find that black inside angle in our triangle. I'll call it theta. All right, part B here. Now that we know side A, we can just do law of cosines. We'll start with the side opposite the angle we're looking for, and we're looking for theta, so we're going to start with 150. 150 squared equals 60 squared plus 95.84 squared minus 2 times 60 times 95.84 times cosine of theta. I really don't want to have to multiply all these numbers out to figure out theta, so I'm just going to keep them and rewrite them and then just plug it all in my calculator at once. That way I'll get the most accurate answer anyways, because I'm not going to be rounding as I go. So we're going to have to subtract the 60 squared and the 95.84 squared from both sides. So 150 squared minus 60 squared minus 95.84 squared is going to be equal to negative, maybe I'll make this 120, 95.84 cosine of theta. Next, we will divide by this negative 120 times 95.84. That gives us that cosine of theta is this fraction. And then to find theta, we just need to do inverse cosine of that fraction. Now be careful when plugging this in your calculator. You're going to want to make sure that your numerator has parentheses around it and your denominator has parentheses around it as well. Rounding our answer to the nearest hundredth, we get theta to be equal to 147.64 degrees. So let's think about what that is. That's our angle theta, but that's not how our boat has to turn. That's the angle inside, the black one, inside the triangle. And what we need is the angle outside of the triangle that is supplementary to this angle. So our answer to part B, our angle B, is going to be 180 minus theta, which is 32.36 degrees. Let's go back and read part C. Part C is asking us how much time has been added to the trip because of being blown off course. Assume the speed remains at 15 miles to the hour, and we'll round to the nearest hundredth. So our boat's track, instead of going the straight 150 miles, it's taking this course. Oh, we've already found our distance A, right, 95.84 miles. So the distance that they're actually traveling is 60 plus 95.84 to give us a total of 155.84 miles. And they want to know how much time has been added. So they're traveling an extra 5.84 miles because the trip was supposed to be 150 miles. But they want to know the time. So to figure out the time, we're simply going to divide by the miles per hour, 15. And we want to round to the nearest hundredth. So our calculator is going to spit out hours. So this is going to be 0.39 hours. But if we wanted to convert it to minutes, depending on maybe the directions asked you to convert it to minutes, all we would do is multiply by 60, and that would give us 23.4 minutes. Law of cosines is a very effective tool for solving application problems, especially ones that involve traveling.